Thank you.
Thanks, Matt. Thanks, Mark. Thanks, everyone, for coming out. Yeah, so I'm Kief. I work for Thoughtworks. Not my title on there, but I'm a distinguished engineer, which, if you're not quite sure what that is, I think that's a feature rather than a bug in the job title. So kind of, I get involved with kind of teams and clients globally, so I get exposed to a lot of interesting situations and all that. The Infrastructure as Code book, the 3rd edition, just came out a few months back, April, May or so. So yeah, I wrote the first one and it came out in 2016, and so stuff is still changing, so there's still kind of room for changes to the book. Yeah, so those are my 2 main kind of, I guess, things to kind of plug about myself. I've also got, I'll have this slide at the end as well if you want to kind of grab like, links or anything like that. So we're going to talk about, I'm going to share some kind of ideas and thoughts based on stuff that I've seen and that my colleagues have seen on projects around infrastructure and kind of ways that we can probably do better with infrastructure and infrastructure automation. Because the promise that we originally had when cloud was new and infrastructure as code was a new thing was that, well, we'll be able to provision the infrastructure that we need when we need it, on demand. Isn't that going to be great? And that because we're going to use this code to define it, that it'll all be very consistent and reliable, and it'll all just be wonderful. Things that we kind of find in reality is that, well, deployments still take a long time, so deploying to environments that we build with infrastructure takes a long time. We end up having to mess with it a little bit too much. Things go wrong, and yeah, it's just more fiddly than maybe we thought it would be. A lot of teams find that they don't have enough environments for testing, so we're kind of like bottlenecked and waiting for other teams or whatever. But at the same time, we also find that we're spending too much on environments. So we have too many environments, but not enough. And I'll go into a little bit more about why that is really. But and then there's like, what are we kind of spending our time on, right? So we're spending a lot of our time on things like, handling deployments and handling issues with deployments, fighting fires, routine stuff, provisioning things that we would think that we could just do automatically, right, on demand and consistently and all that. And it's just kind of not shaping up that way, or it doesn't always shape up that way, let's say. What we really want is, well, software teams should be able to get what they need when they need it, and get and use those to get their software changes and builds into production, reliably and quickly and all those good things. And that as infrastructure engineers, we should be spending our time on things that are improving, adding value, and making things better, rather than on toil. So I want to talk a little bit about how we can kind of how we talk about and measure this thing of slowing us down. And I think this is particularly important when we're having conversations with like management types and we're trying to kind of get approvals to like spend time and money on making improvements to things. It's often useful to have, to be able to kind of talk about the things that they're going to see. What do you get from this, from their point of view? So when it comes to infrastructure, I think that the key thing that you want to measure, and particularly when I'm talking about infrastructure, I'm talking about that kind of getting thing, that path to production, supporting software delivery and these kind of things. And so the way, the kind of real test is in, well, getting the software into production, right? So it's the kind of the Dora-metrics type things that you're probably familiar with, where it's like, well, how long does it take us to get a software change into production? And so this is an example from a client that I was working with a couple of months ago, where their release time is like, it takes 2 to 3 weeks with all the testing and everything to get a build into production. And so as a result, it's only kind of every few months that they're able to get a build into production. And so they're kind of, that frequency of release is quite low. And then they have a lot of failures. Failures, I'm talking about production, like you deploy into production and then you have to do something that you shouldn't have to do. You go in and you fix configuration or clean something up or redeploy bits or whatever it may be. And so these are all things, lots of things can feed into this, and the 4th metric is the kind of recovery time of getting things back up again. There's a lot of things that can affect these metrics. It's not all down to infrastructure, obviously, but I think as if we're taking that lens of infrastructure and infrastructure management, it's useful to think about, well, how does this kind of play a role? What are the different ways that your infrastructure can play a role in improving these kind of outcomes, or where they might be causing issues there. I think a few other things that I like to kind of I guess measure or think about are things like effort. So how much time, and by effort I kind of mean expert, like specialist effort. So how much time do you need whether it's an infrastructure engineer, a DevOps person, somebody who's is basically going to have to, or again, the client that I was talking about, a lot of times their engineering managers would have to get very frequently, they were spending like on average of 2 days a week getting involved in fixing stuff where deployments went wrong and just troubleshooting their kind of messy systems. So I think it's useful to kind of think about that, like how much time are we spending on this stuff, both on like a per change kind of basis and just generally like how many people do we have, does it take to keep everything up and running. Hosting costs and utilization I put together because one of the things about the whole FinOps thing is that there's a real big focus on those costs of the cloud vendor costs, because those are the easy things, right, to look at. I think the kind of flip side thing to also think about is that utilization metric. So how often are the resources sitting idle? And that's kind of one of those things that if we look at that as well as costs, that gives us some opportunities to make improvements. And then technical fitness is a term I use. So it includes things like technical debt, but it's, I think, more than that. So I think technical debt, we tend to think about certain things when we talk about technical debt. And also, again, when we're having those conversations with management types, there's kind of a little bit of a fatigue of technical debt of like, it's fine. We're used to that, right? And so when I talk about technical fitness, there's other, I think, interesting things that we can look at. One thing that I think is worth paying attention to is like versions. How many different versions of things, system elements, whether it's things like your databases or operating systems or whatever, how many different versions of the same thing, do you have deployed anywhere? And then if you think about how long does it take, like when a patch comes out or an upgrade, what's the time between that upgrade or patch becoming available and the point where it's deployed everywhere across all of your systems? And of course, in a lot of cases, that number of how long does it take, it's infinite, right? Because, well, you don't, right? You don't upgrade everything. You have things like 10-year-old versions of OpenSSL or whatever until it becomes a big deal. So that's just kind of one of the examples of some of these things that I think are worth kind of tracking and talking about when we're looking at the health of our systems and how we manage our infrastructure. The thing I'm going to kind of zero in on a little bit today is this capability of providing an environment to deploy a build, and by providing an environment, that might be provisioning a new environment, or it might be just kind of cleaning up an environment and having it ready, or just it might be that it's there. But the useful thing about that is that it's everywhere, right? It's throughout kind of the path to production. We have multiple teams developing parts of the system and deploying it into environments for automated testing from a pipeline, manual testing that might be taking place, any kind of staging or whatever kind of things you have. And typically for a release, this is like multiple times for these, right? Multiple deployments are happening. So if you can, it's one of my favorite things to look at when I'm kind of going into a client and we're kind of dealing with these kind of problems, like I said, where it takes a few weeks to get into production. I look at, well, how long, what is it actually like, what's involved, and how long does it take? Because that has a big impact if you can improve that, right? So a couple of the kind of metrics that I like to dig into specifically for the active deployment, and this might vary based on environment and so on, but and that can be a useful thing to kind of dig into. But it's one of the things is how long does it take before when a build is available for like the previous stage, the previous step in the process? It's like, okay, we're done with this, we're done with the pipeline test, and now the next stage. How long before it's actually deployed and running and working properly in the next environment? And so if you can get that number down, obviously that's a good thing. Related to that is the failure rate. So I was talking about the failure rate before and kind of the sense of production. How often is it that you get something that you think is production ready and then it takes a little bit of extra work there? This is like in environments, even if it's like a developer deploying it to an environment or test it or for testing or what have you. How often, again, does that need somebody to roll up their sleeves and fix something to get it to work versus that kind of ideal case of you click a button or something gets triggered and it's up and running. And so So when I was talking earlier at the very beginning about the not having enough environments, like this is kind of one of those reasons why that can take a long time. Is it's like, well, you have to wait for there's another team testing in the test environment, the stage environment. They've got to change. We've got to wait for them to finish. Or it just might be the deployment process, or the deployment process takes a lot of effort to kind of prepare, and then that can vary again. So. One of the cases I've seen was where they would be doing things like every once in a while, every release or so, they would use a staging environment for performance testing. And so then they do the performance testing and all that. They get the release into production. The next release comes along to be tested into staging, and it's all messed up. The environment has kind of been, weird stuff has been done to it to enable the performance testing, which means that the build doesn't deploy nicely, and they have to kind of work on that. So there's just a lot of different kind of things that can go into this. So one kind of common solution I see is, well, let's not make everybody wait for that staging environment. Everybody have your build of your service or your application ready. Just go ahead and deploy it in there and test it. Doesn't matter if somebody else is testing in there. And then you end up where you're spending a lot of time trying to figure out, why did my deployment fail? Why are my tests failing? Oh, the other team is doing something in there. They've kind of messed with the data to test some of their things. And so you get this kind of conflict and clashes. And then another one is, well, let's have multiple deployment environments, right? Which is that way, everybody can have their own environment to deploy into, their own kind of version of staging or what have you. The issues here, so obviously, assuming these are long-lived environments, then you're going to have a high, you're going to be spending money on those. Utilization is typically, so that whole thing of not enough environments but spending too much environments is typically, it's bursty, right? So we're doing a release, and so we're all waiting to get stuff deployed and tested. Then once the release is over, everything's just kind of sitting there, not being used. And then obviously the effort to maintain and all that, the more environments you have, the more work you potentially have. So, automation, with all of this stuff, I'm kind of assuming there's still automation, because in a lot of organizations I see, they do have infrastructure as code. They are using it to build and update and manage their environments, but still it's a very kind of manual process. So the infrastructure code is very, it's a step above scripting maybe, but it's still like, well, somebody has to do stuff, particularly for changes. We have to make changes to our infrastructure. We're going to need to make tweaks, and so we have to tweak the code. And then we have to tweak the code the same way for the other environments, and that's one of the things that ends up making it take a long time. So the kind of, I guess the thing that I'm kind of advocating here is application kind of driven deployment. So kind of like inverting the way that deployments work. So the typical way, I would say, is bottom-up deployment, right? And so basically it's, first we prepare the environment, we build the environment, we get it ready, even with, again, we're using code for this and all that. And then once it's ready, then we deploy the software. And this happens even when it's the same team, when you have a software development team where the developers are managing the infrastructure for themselves. Often this is still kind of the way that people naturally approach building stuff. But it's even more so when you have separate teams. When you have a separate infrastructure team, it's often the case that, well, they're going to go and build the environments, and then it's up to the developers to kind of worry about deploying on their software onto it. And so you get these kind of handover things where, yeah, your environment's ready. Okay, we deployed. It didn't work. Is it your fault? Is it my fault? Can we fix it? Okay, fix it. Go around again, and you do these kind of loops, and it gets very unhealthy, right? I've seen infrastructure teams. I've seen both things go bad in both directions, right? I've seen infrastructure teams like literally tell me it's not my problem, right? I build the infrastructure works, I can prove it works. If your application doesn't run, that's your fault, that's your problem, right? Not mine. And I've been on the other side where I had developers telling me, well, my application works on my machine, literally. I had that not that long ago from somebody who I would not have expected this from, but it was high pressure situation, and it's like, hey, our application is working, your environment's messed up, so hey, not my problem. And when you have both sides talking like that, you have bigger problems. So that's a real thing. So the idea of application-driven deployment or infrastructure deployment is really where you're having the application is kind of driving, this is what infrastructure I need, right? And so it might be that it actually includes the infrastructure code, or it might be that it has like a specification, and you've got like a control plane that handles the actual deployment, so that kind of GitOps type of thing, or infrastructure as data type of approach. So, but really the key thing is that it's the application is kind of owning, this is the infrastructure that I need, and then the system kind of deploys the right thing. And so, yeah, again, you might have an artifact, or it might be a specification of some kind which says this is my infrastructure, and then you deploy it. This is a fairly simple idea, I think, but just to kind of go a little bit more on the what this kind of means for building infrastructure is that we start thinking more around building infrastructure as a deployable, reusable kind of component that goes into a repository and then can get kind of referred to and pulled when it comes time for deploying an application that might need it. Now, again, a simple idea, there's a lot of kind of complexity to it, or a lot of kind of things that make it get more difficult, especially with larger systems. So the number one thing is often the infrastructure project is quite big and unwieldy, and especially when you've got multiple applications running and using the same infrastructure and having to share some parts of it. How do we manage that? And so the idea here is let's think about how do we decompose our infrastructure code base into separately deployable pieces. And I think it's important to clarify here that if we're talking about, so I've seen some times people think, well, like especially with Terraform, we've got modules, and some modules can do this, which they can as long as you're deploying each module as a separate thing on it with its own project. If you have one project that includes a bunch of modules, you're still kind of back in that monolithic thing when it comes time to deploy it. And when the deployment goes wrong, then you've got to kind of fix all of the whole thing rather than being able to focus on the individual piece here. There are kind of ways of using modules as deployable components or stacks, is what we call them. But this kind of starts opening things up, right? So we can start thinking about, well, what's the infrastructure that a particular application need? What's the infrastructure that's specific to that? So whether it's I need a database instance, I need maybe I'm running on a server or a pool of servers, or networking. I might have application-specific networking like firewall rules or security groups or VIPs or load balancer kind of things that are specific to that application. You can kind of say, okay, we're going to include that, and so that's the kind of thing that the application is kind of specifying. And there, like some ways to do that are to kind of abstract that a bit and say, from the application configuration point of view, I'm just going to say I need to have a connection out to the internet, public connections coming in, right? And then the infrastructure code works out, is the appropriate thing of, okay, well, what does that mean? Setting up certificates, doing all the right things to do that properly. You still obviously, you're often going to have things that are shared by multiple applications. Kubernetes cluster is a super common example where we're going to have multiple applications using it. So, it doesn't belong to one application, so one application can't be the thing that makes it deploy. And so we start thinking about having a more like mixed tenancy arrangements. There's some infrastructure that's application specific. Different applications have different infrastructure needs, some shared things. This tends to become multiple. So rather than having one kind of shared bit of infrastructure, like as a project, as a stack that I've kind of drawn it here, you end up wanting to kind of break that apart into multiple things, maybe a compute stack, maybe a shared networking stack, and those kind of things, so that again, you're keeping them kind of smaller and easier to test and build and debug and deploy and all that kind of thing. And so when it gets more complicated with like multiple teams, multiple groups, all deploying different things into an environment, you may have different layers, right? And so you're thinking about things, so what's the kind of base level stuff that I need for my environment? I'll sometimes call this like a base plane, right? So, and that's like a really minimal thing. And then some things that are shared. So maybe over here we've got like the group doing kind of data and AI stuff. So they've got some special infrastructure that they need that they share amongst themselves. And then other stuff for other groups. I think one of the important principles here is that the dependencies. I'm drawing the arrows, I'm not sure there's the right way to draw the arrows, but basically this stuff shouldn't know about that stuff, right? So what you shouldn't have, what happens a lot of times is people look at this and you get people saying, oh great, as the kind of security specialist, this is where I'm going to put all my stuff and I'm going to control what everybody can do in here, right? And this isn't a governance model, right? So you can put stuff, like I said, you put firewall rules in the infrastructure for your application because that's what it belongs to, and you put your governance around that. You don't try to control everything from the top. This shouldn't know about what applications are running. This should just be like, I'm providing stuff. What you deploy onto it is kind of plugged into it. All right. So you can do some interesting stuff like just enough environment, right? So you're saying, I'm going to deploy my application to run some tests on it, I'm only going to deploy the infrastructure I need. I might deploy a few of those lower levels if it's kind of an on-demand kind of thing for a test environment. But it's kind of like, it ripples down and like, just give me what I need kind of thing. So that's a very quick run through, just as a kind of a few notes on, I guess, overview of like how to kind of go about this. I think the idea is that your infrastructure engineers, people who are building infrastructure, should be building and sharing those composable and deployable infrastructure components. So you kind of need to come up with standards and ways of doing that, tooling and everything, and the application owners giving them a way to select and configure and deploy the infrastructure components that their application needs. So standardizing on these things. And then the governance specialists can provide, so how do you measure and improve the operational quality? So if they're worried about, well, I don't want people opening up network ports and stuff like that, great. So how do you, what tests do you want us to run automatically on that infrastructure component that sets up firewall rules for an application to make sure it's doing the right thing? And where do you want it to be kind of logged to and auditing to take place and those kind of things. So that's it roughly. So I've got in this link here on my website, I've got like a list of some of the kind of tools. This is one of those things where, so I'm talking about these ideas, they're neat and nifty. You tend to have to roll up your sleeves a lot to build this stuff, but some of the things that are out there, these kind of tacos type tools, if you're familiar with those. So these are kind of servers and things that will run like your Terraform or other infrastructure code and kind of manage deployment and all that. A lot of those we're seeing a lot of those emerge with these kind of models of, almost, component models of how do you organize infrastructure other than just one big project. What are ways of doing that? What are ways of sharing code? What are ways of managing configuration of your infrastructure in different environments? And so, yeah, those are hopefully some useful things to give you food for thought on this. Thank you.
Great stuff, Kief. Thank you very much. Right, just time for a couple of questions. Anyone got a question who does not have a pacemaker?
Let's start this mic.
Mark?
I do have one question.
You have a question? Do you have a pacemaker?
It's fine, because we will interview with it.
Fair enough.
So lately there's been a lot of talk about going one level up in infrastructure as code. As you know, as infrastructure as code has been around for a while, there's a lot of abandoned code, orphan code that people have to maintain and they get in trouble, etc. So what do you think of the trend lately of going one layer up and bring your own variable instead of bring your own code? Do you think that's more sustainable?
Bring your own what, sorry?
Variable. So going one level up,
yeah.
Say, just bring your variables, bring what you need to do, and the code will be centrally maintained.
Yeah, I think there's a lot of interesting, so that's kind of what I was thinking of when I talked about, like, say, descriptors or what have you, that the applications say, this is what I need. So it's something that's simplified and in their terms. So I think that's an interesting concept. And there's a lot of, I think getting it right is hard, and especially most of the infrastructure as code languages that we have, like Terraform and CDK and all these kind of things tend to not be awesome at this. They're very flaky. Then there's a lot of things coming out, or experimental things. So there's, what do you call it, infrastructure from code, which is basically like Darklang and Wing and a couple of these. One of them went bust, I think. But but these are ones where you put into your application code actually your kind of annotations of, well, okay, I'm going to store something in a database. Oh, by the way, this is what I need a database, and this is what it needs to have. So I think those are some interesting things. There's a few things coming out. If people are familiar with Weaveworks and some of the guys who ran that, they've got started a new company called Config Hub, where they're working on kind of post-infrastructure as code, and it's kind of more infrastructure as data. System Initiative, which is founded by Adam Jacob from Chef, is also doing some really, really interesting stuff around this. So I think there's a lot of interesting things happening and how to make this work better. But I also see, when I see these things, I also think that they could still easily fall afoul of this, right? Where they're really groovy tools for infrastructure nerds like us to kind of get in there and build really complicated stuff, and then, yeah, come and ask me, and I'll update my, I'll fiddle with these cool tools to make your environment ready for you, so we can end up with a lot of the same kind of bad, difficult situations.
Brilliant, excellent. So that was a bit of a bittersweet question, because that was an excellent question, But Mark is A, disqualified from winning a ticket to AI for the rest of us for the best question, and B, can very easily get a free ticket anyway because he knows Hannah. So the bar is quite high. Where are we going to go?
Oh,
so you two are regulars. I know, you got a question over there? Yeah, okay, I'm going to go there.
Yeah, I'm just curious about the animal on the book.
Yeah.
And in general, what it's like to release a book via that publisher.
I mean, it's pretty good. I could give a whole talk on that. But just the animal in particular. So it's one of these things where you don't get to pick the animal. There's like a small department of like this lady who's been working for O'Reilly for 30 years or whatever, who picks, and this is what you get. This is a Ruppel's griffin, which is a type of vulture that is in Africa. It's endangered. I think quite a lot of not all of the animals, I guess, but a lot of them are kind of on the endangered lists and so on. It's the highest flying bird in the world. It's been recorded at flying, I think, 30,000 feet. Well, it was recorded getting sucked into a jet engine at 30,000 feet, so that's how they know it flies that high. But yeah, no, it's a cool bird.
So writing infrastructure as code is a lot about like dead vultures. Okay.
I think the cloud books were birds. They're kind of cloud in for some. Yeah.
Okay. Was there a question over here somewhere? Okay. Let's go over there.
Oh, hi. My name is Harry. I want to ask about this training, how we can train ourselves in the new age in terms of code.
Mm-hmm.
There's some question, we are going analog computing because it's a power-hungry system. What we are doing nowadays needs a lot of power efficient, and I think that something is going to change.
Yeah. There's some interesting stuff you can. So, just in case people of the recording, the question was around basically around power, what's going to happen or what's happening with power consumption and computing, and how that's going to change things. I don't really know how that's going to change things overall. I mean, yeah, I think it's going to have to change somehow or other. I think there are some interesting things. It's kind of on the level of like, as an infrastructure coding nerd, what can I do? There are some interesting things you can do around making it kind of visible what the power consumption is, and it's not strictly. Sometimes you might think it's like, well, if the cost is for the cloud is kind of an indicator, but actually like different, say, data centers in different regions have different energy footprints and all that. So there are some cloud carbon. There's a toolkit I can't remember the name of, something about cloud carbon, which you can use to help kind of make some of this stuff more visible. So on that kind of micro level, what can I do locally myself? That's one of the things.
Cool. Let's go to Phil.
Hey. So when I'm writing Terraform, I normally have shared repository for shared things. So like you said, the Kubernetes cluster or whatever it is, networking. And then I have a workload repository for that specific workload, like you said.
Yeah.
But in the workload itself will normally require something like, let's say, it needs an IAM role or a firewall rule, like you alluded to.
Yeah.
So it has to be quite highly permissioned just to be able to give permissions to an IAM role.
Yeah.
So how do I keep that secure whilst being able to like delegate to the teams to be able to do their work, basically? Okay.
So the question for the recording is around permissioning. So if we've got like workload specific infrastructure sitting with the code for the application, how do we manage the permissions on that without having to give them enough permissions, or too much permissions, I guess, what's least privilege principle kind of thing you want to do. So one thing you can do is so the code that the infrastructure code that sits with the application, you can have, okay, this is the thing that's going to open the firewall rules or what have you. To actually execute that might be a separate service, right? So this is where it's like you have like here's the code bundle that goes with my application. Pipeline stage picks it up, and it has, whether it's a control plane or within the pipeline, it's got the permissions to actually run the code. And then you might want to put on, like, say, static code checks and things like that to make sure, well, are they doing anything silly with the firewall rule before I exercise that permission? Because otherwise it just becomes like a backdoor. This is, again, you got to roll up your sleeve, because it's like it's a lot of work to make this work nicely. So kind of like coming up with standardization of how to do this, or finding one of these tools that kind of helps you manage this is going to be helpful.
Okay, excellent. Just time for one more question. Over here.
Thank you. You talked about
to maintaining or running environments, setting them up, blowing up, etc. Do you have a view on the potential of orchestrating provisioning of environments with tools such as BMC Control M?
So I haven't used BMC Control M, but I mean, with most of these things, I think if you're going to be using, well, you know, I'm kind of like leaning towards and pointing towards using some tool to orchestrate those infrastructure deployments, right? And I think a part of that should be managing the costs, making them